Hello everyone, this is Mr. McMillan, and I'm here with some example problems on triangle similarity postulates, as well as the other worksheet that we did today together before I posted the other one, okay? So on these first 10 questions, this first sheet here, we want to determine if the triangles in each pair are similar, and if so, we're going to state how we know they're similar. So if you remember from when we talked about triangle postulates the other day, we know that there are three postulates we may be able to use. For similarity, these are angle-angle, or AA, side-side-side, or SSS, and side-angle-side, or SAS. These are the only three that we deal with when we're talking about triangle similarity, okay? So let's look at number one. So number one, you should immediately notice that we have two triangles that are overlapping one another, okay? So that immediately tells us that we have a shared angle here. Do you know where the shared angle is? Well, here we see that triangle RSJ and triangle KLJ have to share angle J. Okay, so that's one angle. Okay, so we have one angle there. Now, there is no other way to tell that we have any other congruent angles. So we cannot use angle-angle because we don't know any of the other angles. However, we do have a side of the small one, or two sides of the small one labeled, as well as two big sides labeled. So if we're going to be using any of these, we're going to be using side angle side. Now, let's determine if we have side angle side. If you remember, the sides need to be proportional. So that means that they need to have the same ratio. So you can figure out which triangle you want to start with, if you want to start with the small one or the big one. So your small triangle, we're going to start with our small triangle first, and I'm going to pick side SJ, and our small triangle is 30, and our large one corresponding is 40. So we do 30 over 40. 30 over 40 simplifies to... So 30 over 40 simplifies to 3 over 4. All right, now we're going to look at our next one. Well, we have a second side for our small triangle, so we're going to start with that one because we started with the small one first. Now you'll notice here that the big angle, or the big triangle, doesn't have the side labeled here. However, we do have these two parts. So what we need to do here is we need to add these two parts to get our other large side. So 8 plus 24 gives us 32. So that will go underneath it. Now if you simplify 24 over 32, you can divide both of them by 8, and that will give you 3 over 4. These ratios are the same, so that means the sides are proportional. So we can indeed say these are similar by side angle side. All right, let's look at number 2. Now number 2, the first thing you should notice about this diagram is that there are parallel lines here. So there's those little triangles on ED and MN. So ED is parallel to MN. Now, we also can see that these triangles have an intersecting line. They meet at that point in the middle at C. And we know that these two angles here of these triangles must be congruent because they're vertical angles. All right, so now we have one angle that's congruent, one pair of angles that's congruent. Do we have any pairs of congruent sides? Well, as you can, or not congruent sides, but sides that are labeled. So we see that none of these sides on either of the triangles have any numbers labeled. So we can't determine if they have the same ratio or not. So the only postulate we might be able to use is angle-angle, okay? But for that, we're going to need one additional pair of angles. So let's see if we can prove that some of these angles are congruent, even though there's no markings. Well, we know that ED and MN are parallel. So I'm going to extend these lines. Okay, I'm going to extend these lines. Now we talked about parallel lines and transversals. So for instance, if I talk about angle D, I see that this here would be my transversal. So there's another angle that's also on the same transversal D is, and that is angle M. Now look at angle D and look at angle M. What type of angles are they? Well, angle D and angle M are on the opposite sides of the transversal, and they're also both in the interior. So angle D and M are alternate interior angles. And if you remember, we talked about how alternate interior angles are congruent. So angle D is congruent to angle M. We found a second pair of congruent angles, so that means that we can say these are similar by angle-angle. Now, likewise, you could have said that E and N were congruent because they are also alternate interior angles. Now, you have to have parallel lines, though, to determine that you have a special angle pair that's congruent. Otherwise, you cannot say that you do. All right, number 3. This similarity statement is just to help you determine the corresponding parts. So just because it's there doesn't mean that they're similar. So let's look at what we have here. In our diagram, we have two sides on both the triangles, and we have an angle that's between those two sides. So if these two triangles are similar, we're going to be looking at using SAS. Well, to do that, we need to make sure that our sides are proportional. So we're going to set up our ratios. Most people prefer to just start with a small one and go over the big one, but it doesn't matter. So we're going to start with 30, and QS corresponds to TV. So TV is 84. We're also going to do our other fraction, 35 over 98. And now we're going to go into Desmos to simplify these fractions real quick, just to make it quicker. So we have 30 over 84, which is 5/14. And now we need to see if the other ratio is 5/14 when simplified. And if it is, then they are congruent, or they are similar rather. And so we see that both of these give us the fraction 5 over 14 when simplified. So since those are the same ratio, we can use side angle side to determine that they are similar. All right, number 4, we have two triangles here and they are overlapping. So we have a small triangle STA and a large triangle CBA. Now, since these triangles overlap, we know that they have to have a shared angle. So the shared angle that they have is at angle A. Okay, so angle A is a shared angle. Now, if we look at the other bit of information in here, we also see that we have some parallel lines here. Okay, so we've got some parallel lines there. Now, the way these parallel lines help us is we can determine if we have some other congruent angles based on the special angle pairs we learned about in parallel lines and transversals. So if we extend these lines out, now this one's going to be different because this time we're not going to be looking at alternate interior angles. We're actually going to be looking for pairs of corresponding angles. So let's look. We've got angle B here. Is there an angle that we can say is congruent to angle B? Well, we could say the angle STA is congruent to angle B. And the reason we can say that is because they are corresponding angles. So they are corresponding angles. So we have two pairs of congruent angles for the triangles. And so that means that these triangles are similar by AA, by angle. Now we could not use side angle side or anything like that because we don't have any sides labeled with numbers. All right, flipping on over. All right, number 5, we've got two triangles here, and we see that this time there are no angles that are labeled with any congruency marks. They don't intersect or overlap or anything like that, so we have to rely entirely on the sides. So we see that we have 3 sides here for both triangles. So the only one we might be able to say they're similar by is side, 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 but we have to verify that first. So let's look at this. We're going to set up our ratios. We have 21 over. Now, since 21 is the smallest side in this triangle, it has to go with the smallest side in this triangle. And you can see that here. AC and JL would have to match up. So 21 over 56. Our next one, 33 over 88. And 39 over 104. Okay. If we simplify these, you can divide both of these by 7. So you divide both of these by 7 and you will get 3 over 8. You can divide both of 33 and 88 by 11 and you'll get 3 over 8. And you can divide 39 and 104 both by 13. And when you do that, you get 3 over 8. Okay. So all of these ratios are the same. So that means that this would be similar by side, side, side. If even one of those was different, you could say that it was not similar by side, side, side. So what I want you to do, I want you to look at number 6 and I want you to determine whether that is similar or not. All right, so looking at number 6, we need to determine if this is similar or not. And what we're going to be looking at here is the sides. So we're going to start our ratio with 28 and then over 49. The next one would be 45 over 77 and 51 over 91. Now if we go to Desmos and we type those in and simplify, 28 over 49 simplifies to 4 over 7. 45 over 77 simplifies to, well, it doesn't simplify, so it just stays 45 over 77. Now, I will tell you, all 3 of these have to be the same. Not a single one can be different. Is 4/7 the same as 45 over 77? No, otherwise they would have simplified correctly. So these would be not similar. All right. So if you want to, you can try the remaining ones on your own and then pause the video and come back to it. We are going to work through each one of these on this video. All right, so number 7, we have 2 sides labeled for both triangles, and we see that we have a pair of vertical angles here, okay? So if we are going to determine these are similar, we're going to do so by side angle side. So let's set up our side ratios to see if they're proportional. So we're going to start out with 8 first, and 8 is going to have to match up to 32. And you can see that SK here and ST in the statement would match up. And then our other one, we have to start back from this triangle, so 10 over 40. 8 over 32 simplifies to 1/4. 10 over 40 simplifies to 1/4. So this would be similar by SAS. Number 8 is very similar to number 7. It's constructed pretty similarly. So angle B, here we see there are some vertical angles, and the postulate we might need to use is side angle side because we have 2 different pairs of sides. So to set up our ratios and test these, we are going to take 27 and divide it by 127, and take 39 and divide by 182. So if we go to simplify these in Desmos, if my screen wants to cooperate with me. All right. So in Desmos, 27 over 127 does not simplify. 39 over 182 simplifies to 3/14. And if you look here, you can obviously tell that 3/14 will not be the same as 27 over 127. So these are not similar. Number 9, we have 2 overlapping triangles here. And so we know that angle R is the shared angle. So we have 1 pair of congruent angles. Now we don't have any sides labeled here. So we're not going to be able to use side, 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 or side angle side. However, we are going to be able to use AA if we have another pair of congruent angles. Well, let's look here. If you have a 54-degree angle here at T and a 56-degree angle here at BCR, is there any way that you could have these 2 angles be congruent, knowing that this one is the same? And the answer is no. So there is no way possible for us to determine a second congruent pair of angles. So since we can't determine a second pair of congruent angles, we would say this would be not similar. And now number 10 is probably the most complex one. Number 10, we are dealing with an overlapping triangle again. So we know that angle S is our shared angle. And you'll see that we have three sides labeled for our long triangle, or our big triangle, and we have only 1 side labeled for our short triangle, the small triangle. However, we can, because we're given the parts here for MT and NU, we can determine what SM and SN are. So SM is part of ST. So we take 52 and subtract 39 and we get 13 for that side. And then SN, we take 48 and subtract 36 to get 12. So now if we do our ratios, you could do all 3 sides if you'd like. So we're going to do 9 over 36 first. Then we're going to do 12 over 48. And then 13 over 52. So 9 over 36 is 1 over 4. 12 over 48 is 1 over 4. and 13 over 52 is 1 over 4. So we can say that these are similar triangles by SSS. However, do you remember the shared angle with angle S? Well, that can also be used to show that this is similar by SAS as well. Okay? So you just have to be very careful about that. All right? And that's it for the triangle similarity postulates worksheet. For the examples on that, we are now going to move on to some problems here. We're not going to do all of these problems. Some of these problems, like number 1, just want you to determine if they're similar. Number 2 wants you to find the value of Z, which is not too much of an issue. But we are going to look at something like number 3, okay? So on number 3, it says, what coordinates for point Z would make triangle ABC similar to triangle ZXY? Now, when we do this, we are looking to plot our points first. So I'm going to use a few different colors here to make sure better differentiate the points. So the first one we're going to put in our standard color here. So -5, 2. In green, we're going to put -5, -6. I don't know if you can tell the difference in that, honestly. In red or burgundy or whatever color this is, we're going to put 5, -6. And then in orange, we are going to put -4, 3. Now, I want to show you something real quick about this. It wants us to determine that these are similar, okay? And specifically, it says triangle ABC is similar to triangle ZXY. So that means that AB needs to match up with ZX, BC needs to match up with XY, and AC needs to match up with ZY. Okay, so that's going to be important when we talk about which point this should be. Now, for similar figures have the same ratio or the same scale factor. So that means if I multiply, or if I have one side to be 5 and the scale factor is 3, I multiply the 5 by 3 to get my new side. So let's look at this. We've got AB. What is the length of AB? Well, AB is 1, 2, 3 units. And CB is 1, 2, 3, 4. And honestly, that's all we need for this since that's a right triangle. Now let's count XY here. 1, 2, 3, 4, 5, 6, 7, 8. And now we need to determine, well, BC matches up with XY. So to get from 4 to 8, you need to multiply by 2. Well, AB is 3. So AB matches up with ZX. So ZX must be equal to 2 times 3, which is 6. So let's look here. We need to see which one of these segments gives us a distance of 6 with the correct side. Now remember, Z is the point that we are plotting. Now we can pretty much tell right here, this burgundy line, that's only 4. So C does not work. And if we look at the orange line wouldn't even form the same shape. So it doesn't work either. So let's look at our green, which is down here, and our purplish that's up here. Well, it's Z, which needs to be connected to X. But it needs to be a straight line connected to X. Well, Z, right here in the green, would connect in a straight line to X, and it's 1, 2, 3, 4, 5, 6 units, which makes B our answer. If we did this point here, it would be connected to Y instead, which wouldn't match up to the similarity statement. Okay. All right, we'll look at number 5 now. And number 5 says, which proportion correctly demonstrates that the figures or the triangles in the figure below are similar? Now, the way you can do this, obviously, is this has a shared angle here. So you know that the sides that are by it need to be the ones that match up if you're doing SAS. However, if the triangles are similar, any proportion that shows that the corresponding sides have the same ratio would work. So let's look at A. A, we have RT over UV. Well, we can immediately rule this one out because RT and UV are not corresponding. Okay, so A does not work. So let's look at B. We've got UV over RS and ST over VT. Now, UV over RS, that works. That's small over big. But when we sit here, ST and VT, those do correspond, but ST is our big triangle, whereas VT is our small. So B does not work. All right, our next one here, VT over ST. So VT over ST works. That's small over big. And then UT over RT, we again get small over big, and those sides all correspond to one another. So C is our answer. And if we look here at RS over UV versus UT over RT, we see that these are big over small is equal to small over big. Okay. All right, now let's look at number 7. Number 7 says to determine the value of X such that the triangles below would be similar. So you're trying to determine X, and with that, you need to set up a ratio. You need to set up a proportion in order to determine what the value of X is. So I always like to start with X on the top of the first fraction. So 4X minus 6 corresponds with the 9. So 4X minus 6 goes over 9. And then we put equal because we're writing a proportion. And then we go back to our original triangle, which would be 24, and then over 12, which corresponds to it. Now we need to cross multiply. So we're going to multiply the 9 and the 24 and the 12 and the 4X minus 6. Make sure, since this has 2 parts, it's a binomial, it has 2 terms, you need to distribute that 12 to both. So 12 times 4X gives you 48X. 12 times 6 gives you 72, and it's negative. And 9 times 24 gives you 216. Then you add 72 to both sides, and you get 48X is equal to 288. Divide both sides by 48, and you get that X is equal to 6. Okay. In some problems, it will ask you to plug in the value of X to find something else, so make sure you pay attention to what the problem wants you to do. All right, now we're going to look at number 8. if triangle BCE is similar to triangle BHL, what is the value of y? So same deal as number 7. We're going to set up a ratio. So y is from our first large one, so y over, and it corresponds to 6. And we're going to set that equal to, now y is from the big triangle, so the only side that has anything on here is this one. Now the big triangle is this entire thing. A pretty common mistake is to use just this part here in order to set up your ratio. So people would say 20 over 15. But instead, you need to make sure you add 15 and 20 because that's the whole thing. So your whole thing is 35, and then over your small one is 15. Then you cross multiply, and you get that 210 is equal to 15y. Divide both sides by 15. And you get that y is equal to 14. Okay. All right. Number 9 would have been determining if triangles are similar and writing the similarity statement, state the postulate, and all that stuff. But we don't need to worry about that. We did plenty of that in the other bit. If you want to try those out, and figure it out, you can pause the video and then I'll tell you what the answers are. But otherwise, we'll move on with the video. So here, 9A would be AA, B would be side, side, side. C, these are not similar. And D, these would be similar by both side, 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 or side, angle, side. So let's look at number 10. Number 10 says, given angle A is congruent to angle Q, prove that the two triangles are similar. So we're writing a proof here, and it says the first reason is given, and in our problem statement, it gives us that angle A is congruent to angle Q. Our next statement says angle ATZ is congruent to angle QTP. So angle ATZ is congruent to angle QTP. And if you notice here, these two angles, the reason they're congruent is because they are vertical angles. So since we have two pairs of congruent angles, we can prove that triangle ATZ is similar to triangle QTP by angle similarity. Okay. And that's going to do it for this video, guys. This is some example problems to help you out with the worksheet. The worksheet, the first 10 questions are similarity, similar triangles, things like that. And the last 6 are on congruence of triangles. So that was what we covered before. You're likely to see something like this on a test or something like that, but we'll talk about those types of problems in a future video. So if you need any help, please make sure to reach out to me, contact me. I hope this video helped, and I will see you in the next video.